Separation of insoluble solid-liquid mixtures. These are mixtures whereby the solid does not dissolve in the liquid, and therefore such mixtures can be separated by two methods: decantation and filtration. We are going to look at each one of them. Filtration. It is used to separate a mixture of a liquid and an insoluble solid. An example of such a mixture is a mixture of sand and water. You realize that when sand is put in water, it settles at the bottom and it does not dissolve. Another example is a mixture of lead-2 sulfate and water. So whenever the two are mixed, same case, lead-2 sulfate settles at the bottom and does not dissolve in the water. Filtration uses a filter paper with very tiny pores through which liquid particles pass easily, but the solid particles cannot pass. The liquid that passes through the filter paper is called a filtrate, while the solid that remains on the filter paper is called a residue. The setup below shows filtration process, whereby we have the filter paper folded and placed on top of the filter funnel, and then the filter funnel is placed on the mouth of a conical flask. Now the solution of water and the insoluble solid, which could be sand, is then poured on the top of the filter paper, whereby the water particles will sieve through as a filtrate, while the residue, which in this case is sand, will remain on top of the filter paper as a residue. Now, when you are asked to separate a mixture containing a soluble and an insoluble solid, an example could be a mixture of sand and salt, then always start by adding water into the mixture. Then stir. The stirring will enable the soluble solid to dissolve in the water. The solid does not dissolve in the liquid, so after stirring, you filter. When you filter, you will obtain the solid as a residue on the filter paper, while the liquid passes through as a filtrate. Evaporate the filtrate to saturation so as to remove the excess water, and then allow it to cool for crystals to form. For example, a question would be asked like this: describe how a mixture of sand and common salt can be separated. So this is how you will answer that question. Add water to the mixture and stir. Common salt dissolves, but sand does not dissolve. Filter to obtain sand as residue and common salt solution as filtrate. Now evaporate the filtrate to saturation so that you allow excess water to leave, and then the remaining solution you allow it to cool and crystallize to form the crystals of common salt, that is sodium chloride. Let's note this. In the above question, filtration and evaporation are used to separate sand and water. So we have used two methods of separation in the same question. Some of the applications of filtration in our lives is: it is used in the large-scale purification of water to remove suspended solid particles from dirty water. Now, most of the water we use in our homes is normally from dams. So this water is pumped into into a purification plant, whereby filtration takes place to filter out any solid particles present in that water. These solid particles could be pieces of plastics rubber, stones, sand, and so on and so forth. So the water needs to be treated in order for it to be consumable, and also to be used for different household activities and also industrial. Now, another application of filtration is it is used in domestic water filters. So in most of those homes whereby water is fetched from borehole and also the spring water, sometimes the water is contaminated with sand, and therefore before it is consumed at home, most rural families will use the method of filtration to be able to filter out things like leaves present in the water, and then it can be clean for consumption in the homes. Now, the other method of separating an insoluble solid liquid mixture is decantation. This method involves allowing the mixture of the insoluble solid and a liquid to settle, and then carefully pouring out the liquid into another container. The decantation setup is as shown in the diagram below. So in this diagram you can see the already settled mixture is being poured along a glass rod into the container. Decantation is not an efficient method of separation because some of the solid comes out along with the liquid, and the glass rod ensures that the liquid is directly poured into the receiving vessel to prevent any spillage and spatter as the liquid flows along it. Now let's move on to liquid-liquid mixtures and their methods of separation. Under this subtopic, we have two categories. One of them is called immiscible liquids. These are liquids that do not mix. They form distinct layers, and a very good example is when you mix kerosene and water. Now, they will form two layers, of course, and they can be separated using a separating funnel. Separation of immiscible liquids using a separating funnel. Now, we find that a separating funnel is used to separate immiscible liquids which form two or more layers when put in a funnel. This method is made possible due to differences in the densities of the liquid. So the liquids must be of different densities so that they may form those two layers. Of course, the dense one at the bottom and the less dense one on the second layer, and like that. For example, a mixture of paraffin and water. Paraffin floats on water because it is less dense than water. Let us see this situation in the next diagram. Now the diagram below shows a separating funnel. Now you are able to see how the two layers of kerosene and water separate in the mixture. And therefore, what happens after this is you open the tap, you run out the water, and place another different container to run out the interface. The interface is normally discarded. Then you will remain with your paraffin in the separating funnel. That way, you will have separated your two immiscible liquids. Now, the use of a dropper and decantation method in separating immiscible liquids is not efficient, and it is usually inaccurate. And therefore, the separating funnel is the best method of separating immiscible liquids. How to separate a mixture of paraffin and water? Let us look at the best procedure. Now, the first thing to do is to remove the stopper from the separating funnel. Then add the mixture of paraffin and water into the separating funnel. Now, of course, water forms the bottom layer and paraffin forms the top layer. Then after that, open the tap and draw out the bottom layer. Discard the interface layer. Then paraffin will remain in the funnel. So that is the right procedure in separating water and paraffin and any other two miscible liquids. Now, what makes it possible to separate substances through this method is, number one, the differences in densities of the liquids. And number two, immiscibility of the liquids. Yani the liquids must be immiscible. So two reasons, differences in densities and immiscibility of the liquids. Now, applications of separation using a separating funnel. Where is this particular method applicable? Number one, it is applicable in the extraction of useful substances from complex mixtures. So sometimes you find that a mixture is too complex, but the moment you put the entire mixture in a separating funnel, then you are able to obtain the most useful component of the mixture as long as their densities are different and they are immiscible. Now, we are done with immiscible liquids. Let's now move on to miscible liquids. Now, miscible liquids are the ones which mix to form an homogeneous solution. An example is the mixture of water and milk. They can be separated using a method called fractional distillation. Now, separation of miscible liquids by fractional distillation. Now, fractional distillation is used to separate miscible liquids with very close boiling points. The fractional distillation is usually similar to simple distillation, which we mentioned earlier, but it is modified to have a fractionating column which enables the vapor of the liquid with the higher boiling point to condense and flow back into the flask. Then it also has glass beads which are put in the fractionating column to increase the surface area for condensation. Now the diagram below shows the separation of ethanol of boiling point 78 degrees Celsius and water of boiling point 100 degrees Celsius. When the mixture is heated, ethanol having a low boiling point vaporizes first, rising to the top of the fractionating column. It then condenses in the Liebig's condenser and is collected as a distillate. It is possible to separate substances through fractional distillation because of their differences in boiling points. So that is one of the factors that make it possible for substances to be separated by fractional distillation. And also, the efficiency of the fractional distillation so that we can obtain pure components can be done by increasing the length of the fractionating column and by making the fractionating column narrower and also using more glass beads in the fractionating column. Those three factors will make the fractional distillation process more efficient and would lead to the production of pure components from the mixture. Some of the precautions to be undertaken during the fractional distillation are: 1. Collection of fractions should be done in conical flasks or a narrow mouth container other than in a beaker to reduce the evaporation of the fraction, especially the highly volatile ones. So whenever you're performing this fractional distillation, ensure the receiving container has a narrow mouth to prevent loss of the product by evaporation, especially those ones which are very volatile, like ethanol. Then also, the thermometer bulb must be at the vapor outlet of the condenser. Now, in some cases, we have the thermometer dipped into the glass beads. And the question in such a case is usually, name one of the mistakes in this diagram. So ensure that the thermometer is at the vapor outlet and not dipped inside the glass beads. Now this marks the end of our lesson today. We have been able to learn about separation of soluble, solid, liquid mixtures. And we have also looked at ways in which we can separate miscible and immiscible liquids. And therefore, attached are some questions which you can be able to look at in order to be able to evaluate yourself on whether you've understood the lesson, the content in the lesson. Till the next lesson, have a nice time. Bye.